Hello everyone. Today I'm going to discuss the third problem of Leetcode Weekly Contest 452, which is minimum moves to clean the classroom. So we are given a 2D grid classroom of m cross n. So the grid can contain different characters. One possible character is S. This means the starting position of the student. L means litter that must be cleaned. R means reset. X means there is an obstacle, and dot means there is an empty space. Now how this is changing, I will take one example and make you understand. So let's say initially it is dot let's take the first example only is dot x and l. Okay, so we are given this is dot xl. This grid is given and we have some other value energy. Okay, energy, let's say E equals to 2. Okay, now from a cell, from the starting cell, we have to go to each other cells and clean the litters. Okay, we have to go to other cells and clean the litter. So initially we are at source and our initial energy is E, which is 2. Now whenever we are jumping to the any other cell, the energy will decrement by 1, so it will be 1 here, and then we'll go to here, the energy will decrement by this is -1 again, and this is -1 again. Here it is 0, and we will remove the litter from the cell. So the total number of operation here is 1 and 1 2. Okay, but there are other possibilities. So let's say this is like s dot dot s dot, let's say s dot r x x l, and let's say we have the same energy value, 2. So whenever we are jumping here, this is becoming 1, the energy will become 1 here. Now whenever we are jumping, the energy is becoming 0. Here we have to reset the energy because we can't jump from 0 to with 0 energy from a cell to any other cell. So we have to reset the energy to, now the energy will be reset to 2. And whenever we are jumping to r to l, so the energy will decrement by 1. So the now new energy is 1. So total number of operations here, total number of jumps needed is here is 3. Okay, so in such, we have to find the minimum number of jumps needed to clean all the litters of all the cells. Okay, now for solving the problem, some observations are required. The first observation comes from the constants. So what are the constants? So the constants are m is 20, n is 20. Okay, the important constants are the most important part of the problem. So what is n? The n could be at max 20. Okay, n could be at max 20. Now m could be at max 20. M could be at max 20. Okay, now, and energy. Okay, energy is 50. Okay, now energy is less than equals to 50. Now from this you can think about some DFS based solution using backtracking. Okay, so DFS based solution means that we are at, let's say we are at some cell r comma c with current energy E. Okay, so this is kind of a DFS based solution with r c e. Okay, but we have to also maintain the state of the classroom. Okay, we have to also maintain the state of the classroom. Let's say RCE does not mean that let's say we are at this cell. Okay, so this cell with energy equals to 2 does not mean we have cleaned the litter in the cell, this cell. Okay, it could be that we have cleaned the litter, and it could be that we have not cleaned the litter. So along with this, okay, RCE, we have to also store the state of the classroom. Okay, now the state of the classroom, there are 400 like the state of the classroom. Now there are many possibilities, right? So state of the classroom we can't really store because each and every cell could be L or anything like that. So state of the classroom we can't store. Okay, now here comes another important observation from the constant, that there is exactly one S in the grid. This is not an observation. The last observation here is that there could be at max 10 L cells in the grid. So what I was saying is that there could be many possibilities for a state in the grid. Okay, so this is the initial state. Let me write. So initial state is s dot r x x and l. Okay, so this is one possible this is one possible state. So I am saying that there could be many possibilities. Okay, many possibilities, because let's say there are all else. Okay, there are all else. So there are all else, let's say, and there is a s here. Let's say there is a s here. So we can change this l, this l, this l. So there are like the total number of l's, let's say, at n. Then total number of possible state in s, because we can clean this later, right? Then this will be an empty cell, so this will be a dot. So a cell, a L cell can be changed to a dot cell. the total number of possibilities, let's say there are k liter cells, then total number of states in this grid will be 2 to the power k. So total number of states in the grid is nothing but 2 to the power k. Now here we are also mentioned that total number of liter cells is 10. So here we can limit that k is less than equals to 10. So this could be also, this k could be also like the state of the grid could also be our recursion parameter. So what I was using, instead of taking the entire state of the grid, I am taking a mask. Okay, so let's say there are 10 liter cells, there is, let's say 10 liter cells, say let's say first liter cell is at 0 0, second liter cell let's say is 0 2. So we'll map the first liter cell with 0, we'll map the second liter cell with 1, like that. Let's say last liter cell is at 10 comma 10, so we'll mark the last liter cell as 9. Okay, so we have mapped, right? Now we will use a 2 to the power 10 mask. Okay, so ith bit is set, means that this liter cell is cleaned, and the ith cell is 1 means cleaned, and 0 means it is not cleaned. Okay, 0 means it is not cleaned. Okay, so that's how we are also maintaining another state. So in our parameter, in a state of the our traversal, there could be multiple traversals, so let's call it a traversal. So in case of a traversal, we have four parameters here: r, row, c, column, my current energy E, and the state of the liter cells. So let's call that mask. So R, C, E mask will be our state of the uh, traversal. Now there are multiple traversals possible. So one traversal is DFS and another traversal is BFS. Okay, DFS and BFS. So in DFS it is hard. I think it could be done with DFS also, but I find it hard when there are like cyclical dependencies in recursion. Let's say from let's say 1 to energy 2 and mask is 0, we can go to like 1 2 2 1, then we can again go to like there could be a cycle. So I am not really confident in going to DFS if there are cyclical state. If you know about how we can approach this problem, please let me know. I will learn something new. Okay, so I am not really confident how we can do DFS, so I have used BFS. So my initial BFS, for BFS we are maintaining a queue. Okay, we are maintaining a queue. Let's say this is our queue. So initial state will be the source I, source row, source column, initial energy, let's call it E, and initial mask is 0 because we have not cleaned any of the later cells. So from SR SC E0, we'll go, let's say we are at some cell SR comma SC, we'll take all its four neighbors, we'll check all its four neighbors, and let me go to the code, you'll understand better how we are making the transitions in the BFS. Okay, so here I have initialized my DP array. Okay, DP array means this is kind of a visited array or distance array. Like what is the like initial this SRSC E0, the DP of this, like the distance of this will be 0, and whenever we are going from a cell to any of its neighbor, the distance will increment by 1. Okay, so initial distance is marked as 0. Initial distance is source I, source J 0, mask is 0, and energy is marked as 0. So row, column, row is U0, column is U1, mask is U2, and E is E3, U3. U is the tuple what we are storing in the queue. Okay, now our new mask is mask and new energy is E. Now if classroom row column is equals to L, then this means that this cell contains a liter. So we are just taking the index is lit liter of row column. So here you can see that we are mapping the mapping I have explained you na, that we are mapping 0 0 to 0, 0 2 to 1, like that. That is our liter. Okay, so liter index is liter of row column. So we are doing new mask or equals to 1 2 to the power index. Okay, so this means that we are clearing the liter in the cell, so we are marking that specific bit as 1. Okay, now if new mask is 1 2 to the power k minus 1, that means we have cleaned all the liter. Now we are doing a BFS, that means this is the minimum possible number of moves we can reach at new mask. Okay, so this is the minimum possible moves we can reach at new mask. So new mask is 2 to the power k minus 1. That means we have cleaned all the litter, and this is the minimum number of moves we have reached. So the total number of moves is dp, row, column, mask, and e. So we are setting answer as dp, row, column, mask, and e. We are breaking. Okay, now if classroom row comma column is equals to r, okay, that means we can reset. So we are setting new energy as the original energy, and now will move to any of the neighboring cells. So the energy will decrement by 1. So we are doing any minus minus. So we are checking for all the possible 4 neighbors. So this is part is which, let me explain for one case. So we are checking that row plus 1 comma column, that means the cell, bottom cell. Okay, so if it is valid will check that if the row less than 0, if the row is between 0 and n, column is between 0 and m, and the e is my energy is greater than equals to 0, and my classroom is not blocked. Okay, classroom cell is not blocked, and my dp will check that if the cell is not visited. Dp means that the cell is visited, the current state is visited, row plus 1 column, new mask, and new e. If it is not visited, then we are marking it as visited with the distance, the current distance plus 1, and we are pushing that tuple in the queue. Okay, and we are initializing answer is minus 1. So if we don't reach this state ever, new mask is 2 to the power k minus 1, we'll just return minus 1 from there. I hope you understood my solution. That what is the time complexity of the solution? Okay, the time complexity of the solution is order of uh, n m 2 to the power k into e. Okay, k is the number of liter cells. So here you can see that it is like 20 into 20 into 2 to the power 10 into 50. This is the overall maximum time complexity. I hope you get it. I will provide the link of the code in the description box. You can check that out. If you find this video helpful, please like the video, subscribe to the channel, and also share among your peers. Thank you.